time interval?
Yes, this is for it's being used in the next time, in the next iteration.
Next iteration or next evaluation interval?
No, next iteration. So each evaluation interval is treated in the same way for each run. So it's just, so for example, we have several intervals. That means we are going to perform dynamic assignment several times in this run, in this iteration. And this function is used for calculating the travel time between iterations, not intervals. And here you will be able to specify, let me use my magnifier. In the middle of the dialog, you can create this evaluation interval, specify this, and if you click this, here is store cost, search new path. Here is a dialog called store cost, and to its right it has a button called extended. Then you can specify the factors for either exponential smoothing or MSA. I mean, two methods, the parameters you can specify. Okay, so where's my magnifier? Couldn't find it. The next thing I want to talk about is called utility function. So let's suppose for each route, each edge, not each edge, each route, we have a general cost. And for this cost is the smaller the better. So we create a utility function to reflect that by calculating the inverse of the general cost. And after we get the utility function, there are, in Reason, the first way to use it to select several paths. I mean, for each path we have a cost, and then we can create its utility. The way to select the utility, to select the path, is by this logic function. When we do, this is first type of function we can use, but it's not used in route choice. It's used in parking lot choice. But let me explain this first. This is the model. So the probability of selecting route J is equal to e to the power of a factor mu multiplied by this utility and divided by sigma of this e to the power of mu utility something. This is called the logic model. It's a very basic model in the field of discrete choice modeling. But this has a disadvantage in route choice, so that's why they didn't use it. The reason behind that is, by using this discrete choice modeling, this logic model, there will be no difference between 5 and 10 and 105 and 110. So if the cost is 5, the costs are 5 and 10. And in other case, the costs are 105 and 110. By using the logic model, we get the same probability distribution. So that's why they don't want to use it. They say 5 miles per hour or 5 minutes and 10 minutes are much greater difference than 105 hours than 105 minutes and 110 minutes. So they use another distribution called Kirchhoff distribution. And this is another form. So the probability is equal to U utility to the power of this sensitivity factor, which you can specify, divided by the sigma of it. So in this case, 5 and 10 is different than 105 and 110. And you will be able to select them, to specify them in the middle of this dialog. So these are parameters you can choose, you can define by yourself, and they have default values. Now, another thing is called the correction of overlapping path. There is a function in Vsim that can do this, correction of overlapping path. So this is a simple assignment. So these paths and that path are of the same cost. And as a result, you are going to assign half of the volume to the upper part and half of them to the lower part. That's very natural, right? Consider this situation. If the upper part has a branch at the end of the path, and that will bring 3 paths from A to B. And as a result, this part, using the traditional method, will get 2/3 of the volume. And in Vsim, sometimes this problem can be solved by using a function called correction of overlapping path. And the reason, the logic behind that is that they are using a commonality factor. So if these 2 paths are having a lot of links or edges in common, you will be given less weight. But be very careful when you use it, because if you use this method, typically you are going to assign more traffic to the longer path. So they don't recommend you to use it very often. But this is a function, an option you can use. Just here. Correction to overlapping paths in the middle of the dialog. See that? Can you see that? Okay. So the next one, next thing I'm going to talk about is detour factors. Detour factor means when you are searching for the routes, you don't consider those paths that are very, very long and much longer than the shortest path. For example, if you define the detour factor as 2, then you find the shortest path. Then any path that is longer, twice as long, or more than twice as long as the shortest path will not be considered, will be completely discarded. So this is factor you may want to use. And route guidance is like here. If you go to view and go to base data and vehicle types, and you edit any vehicle type, here is a type called special, and a special. Yes, in special, you are going to see the equipment of each vehicle type. If you select route guidance 1 or route guidance 2, then this vehicle will be considered to have some equipment. And this equipment can let the vehicles dynamically choose the best route. And this route guidance doesn't need to be installed somewhere. It's a virtual device or virtual system. And only those vehicles that are equipped with this route guidance system can benefit from that. The next thing is called convergence. And sometimes, in order to get the user equilibrium, you run the model several times. For example, 100 times. But you want these 100 time iterations stop when it reaches convergence. So if you still open this dialog, here is a button called convergence. This is a button called convergence. If you click this convergence button, you can see, you can select from one of these convergence criteria. And they recommend you to use only one, maybe travel time on path. So if the travel time on each path are kept within 15% of the last run, then it's considered as convergence, and the multiple run will stop. Now let me talk about general cost I mentioned. In Vsim, the general cost of each edge, which may contain several links actually, is calculated by alpha multiplied by travel time, and beta multiplied by travel distance, and gamma multiplied by financial cost, and sum of the supplement 2 parameter of each link, of every link. And this financial cost is equal to the travel distance of a link multiplied by a parameter called cost and plus sublinear 1. So these blue things, these light blue things, are parameters that you can define by your own. So let me still open the base data on vehicle types. For each vehicle type, if you go to special and cost efficiency, you will be able to define alpha, beta, and gamma. And for each link, it has a tab called other and a button called cost. And here you will be able to specify 3 other parameters. And that was for route choice. The next thing is called parking lot choice. So if you have several parking lots that are associated with like zone 1, then you have an OD matrix from zone 1, starting from zone 1. Then where will the trip begin? So here is the utility function of parking lots. It is just several ways associated with the parking cost and attraction, which means I didn't list it here, and the direct distance between the parking lot and destination and something like that. And this is using the logit model. So Kirchhoff model is used in route choice, and parking lot choice is using the logit model. And that's the reason you want to modify these parameters in the DTA, dynamic assignment dialog. Now I have already mentioned you can, let me just give you an example first. So in this network, I have already specified the OD matrix. Then if I run it for the first time, let's see the result. You are going to see all the vehicles are using the upper part. All the vehicles are going through the upper path. The reason behind that is that one is this is the first time we run it. In the first time we run it, it's only using the shortest path. So this second shortest path is not recovered. It's not discovered. And there is a trick. When you are running Vision, sometimes you feel it's a bit slow, so you minimize it, so it doesn't have to plot the graph. Then it runs much faster. And let me just okay. So this run has has an 1 hour, so I just minimize it, and it's much faster. So it's done. Okay. So that's the first iteration, and if I run it twice, oh, you miss. Well, I see. So the second time you are going to see all the vehicles are going through the lower path. This is iteration 2. So every time when you run the Vision model, it's trying to discover a new path. If a new path is found, the vehicles are going to use the new path.